A bakery sells 4 different types of bread. How many combinations of 3 different types of bread can a customer buy from this bakery? So you might be tempted to break out your combinatorics that you've learned, and you'd say, well, this is going to be, I have 4 different things. From 4 possibilities, I am going to choose 3. So it's going to be 4, choose 3. And you might remember a formula here, or you might be able to reason through a way to rederive the formula for what 4, choose 3 is. Or you could just do this brute force. And what we'll see is this is actually not too hard to do in a brute force type of way. So we have 4 different types of bread. Let's say you have type A, type B, type C, and type D. So let's try to figure out as many combinations as we can. Well, for each combination, we're going to pick 3 different types of bread. So essentially, we're going to leave out one type of bread. So for example, our first combination, let's leave out type D. So our first combination could be A, B, and C as the 3 that we picked. Now our second combination, let's leave out C. So it would be A, B, and D. I think you see where this is going. Our third combination, let's leave out B. So it would be A, C, and D. And for our fourth combination, let's leave out A. So it would be B, C, and D. And those are all of the possible combinations here. Each of the combinations, since I'm picking 3 out of 4, I'm essentially leaving out 1. So there's one where I leave out D, one where I leave out C, one where I leave out B, one where I leave out A. So there are 4 possible combinations. Now, that's all we had to do, but if you went this route, you should also get the same result. And there's a couple of ways that you could think about 4, choose 3. The way that I always think about it is, well, look, I have 3 buckets here. I'm picking 3 out of the 4 possibilities. For my first bucket, I have 4 possibilities. Second bucket, since I already used up one of the possibilities in the first one, I have 3 possibilities. Third bucket, since I already used 2 of them, I have 2 possibilities. And so I would multiply these possibilities. 4 times 3 times 2 is 24. But that's actually not the total number of combinations. This would be essentially the number of permutations here. But since we don't care about order, we want to divide by the different ways that you can order 3 things. So you can order 3 things in 3 times 2 times 1 ways. So for one way to think about it is that this one could be in 3 different places. This one, if this is in 3 different places, this one could be in one of the 2 remaining places, this bucket. And then this one would be in the 1 remaining place after you've put these after you've ordered these 2. So you would divide it by 3 times 2 times 1. So you divide by 6. And so this would be equal to 4 combinations. Or, and this is the one that I would least recommend, I would recommend this one, especially if you're on the SAT. It's very unlikely that they would give you something that is, required memorizing some formula that they didn't give you. But you could say, well, look, you might remember that from your algebra class, that if someone says n choose k, how many combinations can you pick k things from a set of n, that this is going to be equal to n factorial over k factorial times n minus k factorial. And in this case, it's going to be equal to 4 factorial over 3 factorial times 4 minus 3 factorial. Well, that's just going to be 1 factorial times 1 factorial. So it's 4 factorial over 3 factorial. That is 24 over 6, which is once again equal to 4.